What if the oldest evidence of human ingenuity wasn't found where we've been looking, but buried beneath layers of earth that predate the very idea of civilization itself? What if the tools we've discovered, carefully shaped by hands we cannot name, whisper of minds that understood forces we only recently learned to measure? Stand with me now, in the cool dark of a cave no sunlight has touched in tens of thousands of years, where the walls hold pigments mixed with a precision that defies our timelines, where the ground beneath our feet preserves something we're only beginning to understand. This is not the story they taught you. This is the story that sleeps in stone and bone, waiting for us to remember what we've forgotten. Before we descend further into this mystery, if you're drawn to the kind of history that refuses easy answers, the kind that asks you to question everything you thought was settled, consider leaving a like. Subscribe only if you're ready to walk with me through the shadows of our past, where certainty dissolves and wonder takes its place. And tell me in the comments below where you're listening from tonight. Are you in a city built atop older cities, or in a place where the land still remembers what came before? Your presence here matters. You're part of this inquiry, this shared search for truth in the darkness. We begin with a simple assertion, one that has stood unchallenged in textbooks and museums for generations. Human civilization, we're told, emerged roughly 12,000 years ago in the Fertile Crescent, a gradual awakening from nomadic wandering to settled agriculture, from crude stone implements to sophisticated metallurgy. The narrative is linear, progressive, comfortable. First came the hunters, then the farmers, then the builders. Each innovation a stepping stone, each generation slightly more advanced than the last. The archaeological record, we're assured, confirms this steady march forward. But what happens when the record refuses to cooperate? What happens when tools appear in layers they shouldn't occupy, when evidence of knowledge surfaces millennia before that knowledge should exist? In the summer of 1966, deep in the Huitlaco site near Valsequillo, Mexico, archaeologists unearthed something that should have been impossible. Stone tools, sophisticated bifacial implements crafted with clear intentionality, embedded in geological strata dated to over 200,000 years ago. Not 12,000. Not 50,000. 200,000 years ago, when according to every model we possess, anatomically modern humans had not yet left Africa, when the Americas were an empty stage awaiting actors who wouldn't arrive for another 180,000 years. The tools were tested, retested, analyzed by multiple laboratories using different dating methods. Uranium series dating, tephra analysis, geological correlation, all pointed to the same impossible age. The implications were staggering, unacceptable. The findings were disputed, marginalized, filed away as anomalies, errors, contamination. But the tools remain, silent witnesses in museum storage, asking their question across the centuries. Who made us? Whose hands shaped our edges when no hands should have been here at all? Consider what a tool represents. It is not merely an object, not simply a sharp edge or a weighted stone. A tool is frozen thought, physical proof of abstract reasoning, of cause and effect understood and manipulated. To create a bifacial tool requires planning, requires the ability to see in your mind the form hidden within the stone, requires knowledge of fracture mechanics, of angles and force and material properties. It requires teaching and learning, culture and transmission. These are not the marks of primitive proto-humans stumbling through their world. These are the signatures of minds fully awakened, fully human. And if those minds were here, crafting their implements in the dust of an ice age we've forgotten, then our entire framework collapses. The comfortable progression shatters. We're left standing in the ruins of our certainty, asking questions we don't want to answer. Move with me now, thousands of miles north and forward through time, though time itself becomes slippery in this landscape. White Sands National Park, New Mexico, where the gypsum dunes stretch like frozen waves beneath an endless sky. In 2021, researchers analyzing fossilized footprints preserved in ancient lakebed sediments made an announcement that sent tremors through the archaeological community. The footprints, human footprints, adults and children walking together across wet mud, were dated to between 23,000 and 21,000 years ago. Again, an impossibility. The Clovis people, long held as the first Americans, arrived perhaps 13,000 years ago, crossing the Bering Land Bridge as glaciers retreated. These footprints predate them by 10,000 years, made when massive ice sheets still sealed the route from Asia, when the journey should have been impossible. The prints are clear, unmistakable, pressed deep into earth that turned to stone, holding the weight and gait of people who should not exist in our timelines. The scientific community responded with predictable skepticism. Dating errors were proposed, contamination suggested, alternative explanations offered and retracted and offered again. But the footprints endure, and with them, dozens of other sites across both American continents that hint at human presence far earlier than the models allow. Pedra Ferreira in Brazil, with its painted rock shelters and charcoal dated to 30,000 years or more. Monte Verde in Chile, its wooden structures and medicinal plants preserved in peat, pushing occupation back to at least 14,500 years, perhaps far longer. Bluefish Caves in Yukon, where modified bones suggest human activity 24,000 years ago. Each site contested, each date disputed, each piece of evidence picked apart by those invested in the established narrative. But the pattern persists, a constellation of anomalies that refuses to be dismissed as mere error. Something happened that we haven't accounted for. Someone was here, walking and working and living, while our textbooks insist the continents lay empty. What draws us to these mysteries, these cracks in the foundation of our accepted past? Perhaps it's the recognition that history is not a fixed thing, not a settled account but a living negotiation between evidence and interpretation, between what we find and what we allow ourselves to believe. The narrative of human origins has shifted dramatically even in the span of a single lifetime. When your grandparents were young, Neanderthals were portrayed as brutish cave dwellers, extinct dead ends on the tree of humanity. Now we know they were sophisticated craftsmen, artists, sailors even, and that their DNA flows through most of us, a genetic whisper of ancient meetings and minglings. What we thought we knew dissolved in the light of new evidence. What we believe now will likewise dissolve, replaced by understandings we can barely imagine. This is the nature of discovery. This is the humility required when we dig into the deep past. Let's examine more closely what the conventional model tells us, not to mock it but to understand its structure, its assumptions. According to the prevailing theory, anatomically modern humans evolved in Africa somewhere between 200,000 and 300,000 years ago. They remained there, relatively isolated, until approximately 70,000 years ago when small groups began migrating outward, into the Middle East, then branching into Europe, Asia, eventually reaching Australia by perhaps 65,000 years ago. The Americas, separated by vast oceans and ice, remained unpopulated until much later, accessible only during narrow windows when sea levels dropped and land bridges emerged. The Bering Strait route opened around 15,000 years ago as glaciers retreated, allowing the first humans to enter a pristine, game-rich wilderness. These first Americans, the Clovis people, rapidly spread southward, their distinctive spear points marking their passage, reaching Tierra del Fuego within perhaps 1,000 years. A beautiful story, elegant in its simplicity, supported by decades of archaeological work and genetic modeling. But like all beautiful stories, it begins to fray when scrutinized too closely, when new evidence refuses to fit the established pattern. The DNA tells a strange tale, one that grows stranger the more carefully we listen. Genetic studies of Native American populations reveal multiple founding lineages, waves of migration occurring at different times, some separated by thousands of years. The majority of ancestry traces back to East Asian and Siberian populations, exactly as the Bering Land Bridge model predicts. But there are outliers, genetic signals that don't fit neatly into the framework. Some South American populations carry traces of ancestry more closely related to Australasian and Melanesian peoples, a genetic signature found nowhere in North America, suggesting either an independent coastal migration route or mixing with now extinct populations that arrived via a different path. Other studies have identified what researchers call ghost populations, ancestral groups detected through statistical analysis of genetic variation but having no living descendants, no archaeological remains we've yet identified. They exist only as shadows in our genomes, proof that the story is more complex than we imagined, that migrations overlapped, populations mingled and vanished, that the human journey to populate the globe was not a single arrow but a tangled web of movements, meetings, disappearances. Consider the sheer audacity of those journeys, whoever made them, whenever they occurred. Imagine standing on the eastern shore of Siberia 50,000 years ago, the ice grinding and groaning inland, the ocean stretching gray and hostile to an invisible horizon. What drives a group of humans to venture into that emptiness, to build boats or rafts or simply to walk across frozen channels, not knowing what lies ahead, not knowing if land exists beyond the edge of sight? This is not desperate flight, not aimless wandering. This is purposeful exploration, calculated risk-taking, the same impulse that sent us later to the moon, to the depths of the ocean, to the limits of human endurance. Our ancestors possessed courage and curiosity that we can barely fathom, living as we do in our mapped and measured world. They stepped into absolute uncertainty and kept walking generation after generation, across continents, across climates that shifted dramatically within lifetimes, adapting and surviving and somehow impossibly thriving. Now return with me to those caves, those painted chambers sealed in darkness for millennia. Chauvet Cave in southern France, discovered in 1994, its walls adorned with over 400 animal paintings and engravings, dated to 32,000 years ago or more. The artistry is not primitive, not the crude scratchings of barely sentient beings learning to represent their world. These are sophisticated compositions, utilizing perspective and shading, capturing motion and anatomy with stunning accuracy. The artists understood the contours of the cave walls, used natural bulges and curves to give their animals three-dimensional form, placed them in scenes that suggest narrative, story, meaning beyond mere documentation. The pigments themselves reveal knowledge of chemistry, of mixing minerals and binders to achieve specific colors and consistencies, of preparation and application techniques that wouldn't be rediscovered in European art for thousands of years. Radiocarbon dating of the charcoal used in the drawings confirms their age, as does uranium series dating of the calcite that formed over the paintings, sealing them in stone. This is not contested. This is accepted fact. And yet it forces us to confront an uncomfortable reality. 32,000 years ago, humans were creating art indistinguishable in quality and sophistication from works produced in any later period. The capacity was there, fully formed, waiting. But we're searching for something more specific now, something that resonates with our title, with the idea of measuring forces that Newton wouldn't formalize until the 17th century. We need to look deeper into the very structure of how these ancient people interacted with their world, what they observed, what they calculated, what they somehow knew. The evidence is scattered, fragmented, controversial, but it exists if we're willing to see it. Megalithic structures around the globe, built thousands of years before the pyramids, demonstrate astronomical alignments so precise they could only have been achieved through generations of careful observation and mathematical calculation. Göbekli Tepe in Turkey, dated to 11,600 years ago, its massive stone pillars carved with animals and symbols, its circular enclosures aligned to celestial events, built by people we classify as hunter-gatherers, pre-agricultural, pre-civilization. How? With what knowledge? With what purpose? The question of purpose haunts us when we stand before these monuments. We default to ritual explanations, religious significance, because we cannot imagine practical applications for such efforts expended by societies we label primitive. But what if we're looking at it backwards? What if the ritual grew around the practical, around observed phenomena that demanded explanation, around measurements taken and recorded in the only permanent medium available, stone? Consider the megalithic yard, a unit of measurement identified by Alexander Thom in his surveys of British stone circles, appearing consistently across hundreds of sites spanning thousands of years. This wasn't random placement of boulders. This was standardization, mathematics, a shared system of measure implying cultural continuity and transmitted knowledge. Why would pre-literate people need such precision? Unless they were measuring something that required it, tracking something that mattered deeply to their survival or understanding of the world. The standing stones at Karnak in Brittany, over 3,000 of them arranged in rows stretching for miles, aligned with solar and lunar events, built between 5,000 and 3,000 years ago. Walk among them at dawn and you can still feel what they're doing, how they mark the turning of seasons, the cycles that govern planting and harvest, life and death. But they're doing more than that. The stones create sightlines, calculate angles, predict eclipses, and code in their placement information about the movements of celestial bodies with an accuracy that suggests not casual observation but systematic study spanning generations. These were observatories, permanent records of accumulated data, stone computers calculating realities their builders couldn't directly perceive but somehow understood. The mathematics involved requires abstract thinking, requires understanding of geometry and trigonometry, requires the ability to plan and execute constructions that will outlast their creators by millennia. This is not the work of simple farmers marking time. This is science, rendered in granite and aligned to the stars. Let's push further, into realms where the evidence becomes even more contentious, where mainstream archaeology falls silent and we enter territories guarded by skepticism and ridicule. There are researchers, careful and credentialed, who've examined ancient structures and found engineering solutions that seem to exceed what we'd expect from the claimed time periods. The precision fitting of massive stone blocks at Sacsayhuaman in Peru, some weighing over 100 tons, shaped and placed with tolerances measured in fractions of millimeters, no mortar, no space for a blade between them. The conventional explanation involves bronze tools, wooden rollers, and immense manual labor. But when engineers today attempt to replicate these methods, they struggle to achieve even a fraction of the precision evident in the original work. The stones aren't just heavy, they're irregular, each one unique, requiring the cutting and fitting of complex three-dimensional puzzles that would challenge modern computer-aided design. How was this accomplished? With what tools, what techniques, what understanding of materials and forces? Some researchers have proposed that the builders understood principles of leverage and counterweight in ways we've lost, that they possessed knowledge of acoustics and resonance that allowed them to move massive weights using sound and vibration, methods that sound like fantasy but which recent experiments have shown possess at least theoretical plausibility. Others point to the chemical analysis of stone surfaces showing signs of geopolymer technology, essentially ancient concrete that was poured and molded rather than carved, though this remains hotly disputed. What's undeniable is the precision itself, the evidence that someone at some point solved engineering problems we're still struggling to understand. They measured and calculated and constructed in ways that demonstrate mastery of physics, even if they didn't call it by that name, even if their framework for understanding was utterly different from ours. Now, consider gravity itself, that invisible force pulling us toward the Earth's center, the force that governs the fall of stones and the orbit of planets, the force Newton finally quantified in his law of universal gravitation. To measure gravity requires sophisticated instruments, sensitive scales, controlled experiments. Or does it? What if there are indirect ways to perceive and calculate gravitational effects, methods available to careful observers with time and dedication? The period of a pendulum depends on gravity and length. Vary the length, time the swings precisely, and you can calculate the local gravitational acceleration. Ancient peoples certainly had pendulums, used them in various contexts, though whether they performed such experiments remains speculative. The flight of projectiles, the arc of thrown spears or stones, follows trajectories determined by gravity. Observe enough throws, measure enough distances and angles, and patterns emerge that encode information about the force governing the motion. Did ancient hunters, whose survival depended on accurate throwing, develop an intuitive or even mathematical understanding of these principles? The enigma deepens when we examine ancient weights and measures. Systems of measurement across disparate cultures show curious correlations, ratios that relate to planetary dimensions, to the size of the Earth itself, to gravitational constants. The Egyptian royal cubit, the Sumerian double hour, the measurements encoded in the Great Pyramid, all demonstrate relationships to geophysical and astronomical realities that seem too precise to be coincidental. The Great Pyramid's base perimeter, divided by twice its height, yields a number remarkably close to pi. Its location at latitude 29.979 degrees, nearly 1/30th of the distance from equator to pole, seems to encode information about Earth's shape and size. The structure's mass and the geophysical constants of the planet bear mathematical relationships that researchers have puzzled over for centuries. Are these correlations accidental, the result of us imposing patterns on random data? Or did the builders possess knowledge of Earth's dimensions and properties? Knowledge that required measurement and calculation, knowledge that implies abilities we haven't credited them with? We must be careful here, threading the line between open-minded inquiry and unfounded speculation. The history of alternative archaeology is littered with claims that crumble under scrutiny, with patterns that dissolve when examined rigorously, with ancient astronauts and lost Atlantean supercivilizations built more from wishful thinking than evidence. We're not advocating for those narratives. We're asking simpler, harder questions. We're looking at specific artifacts, specific structures, specific evidence that doesn't fit comfortably into our models, and asking what it means, what it implies about the capabilities of our ancestors. We're pushing back against the tendency to underestimate ancient peoples, to assume that because they lacked our technology, they lacked our intelligence, our curiosity, our capacity for rigorous observation and logical deduction. Think about what observation alone can teach you, given enough time and attention. Stand in the same place night after night, year after year, and watch the stars will overhead. You'll notice patterns, cycles, regularities that allow prediction. Without telescopes, without computers, without even writing in some cases, ancient astronomers mapped the heavens with astonishing accuracy. The Mayans calculated the length of the solar year to within seconds of our modern measurement. The Babylonians predicted eclipses centuries in advance using mathematical models inscribed on clay tablets. The builders of Stonehenge aligned their stones to solstices and lunar standstills spanning 18.6-year cycles, demonstrating multi-generational observation programs. This is sophisticated science, systematic inquiry producing replicable results, even if conducted within a mythological framework we've since abandoned. The question isn't whether ancient people were intelligent, capable, curious. The question is how far back that intelligence extends, how much knowledge has been lost and found and lost again across the vast stretches of human time. Let's examine a specific artifact, one that encapsulates this mystery beautifully. The Antikythera mechanism, recovered from a Roman-era shipwreck off the Greek island of Antikythera in 1901, initially dismissed as meaningless corroded metal, later revealed through X-ray analysis and painstaking reconstruction to be an intricate mechanical computer, a clockwork device using dozens of precisely cut bronze gears to calculate and display astronomical positions and eclipses, to track the metonic cycle relating solar and lunar calendars, to predict the timing of ancient Olympic Games. It dates to approximately 100 BCE and represents a level of mechanical sophistication not seen again until medieval European clockwork, over 1,000 years later. When it was found, experts initially couldn't believe it, couldn't accept that such technology existed in the ancient world. It shattered assumptions about ancient capabilities, forced a recalibration of what we thought possible. And here's the truly unsettling part. It's not a prototype, not a crude first attempt. It's a refined, sophisticated device, implying a long tradition of such instrument making, implying knowledge and techniques that were lost, forgotten, erased from the record. If one survived by accident, preserved in the anaerobic environment of a shipwreck, how many others were melted down, corroded to nothing, lost to time? The mechanism forces us to ask what else we've lost, what knowledge was once common that we've had to rediscover painfully over centuries. Ancient batteries found in Mesopotamia, crude but functional, generating weak electrical currents for purposes we can only guess at. Damascus steel, whose crystalline structure and exceptional properties we've only recently learned to replicate. The original forging techniques lost when the last smiths died without passing on their complete knowledge. Greek fire, the Byzantine Empire's secret weapon, a flammable liquid that burned on water, whose exact composition remains unknown despite centuries of speculation and experimentation. These aren't myths, they're documented technologies that existed and vanished, leaving us grasping at fragments, trying to reconstruct what our ancestors knew. If so much can be lost in the relatively well-documented classical and medieval periods, how much more has been lost from the deeper past, from times before writing, before permanent records, when knowledge lived only in human memory and skilled hands? Consider the magnitude of what we're suggesting. If human cognitive capacity, the hardware of our brains, reached its current state 50,000 years ago or more, then the primary variable across history isn't intelligence but accumulated knowledge, cultural transmission, the ability to build on previous generations' discoveries. A child born in the Paleolithic has the same potential as a child born today. Place them in different environments, give them different tools and teachers, and they'll achieve different things, but the underlying capacity is identical. This means that anything we can conceive, they could conceive. Anything we can observe, they could observe. The difference is infrastructure, is writing systems to preserve knowledge, is dense populations allowing specialization, is material abundance freeing some individuals to spend lives in pure inquiry. Remove those advantages, scatter humans in small bands across vast territories, force constant migration and survival struggles, and accumulated knowledge becomes fragile, easily lost, each generation relearning basics rather than advancing frontiers. But in rare moments, in favorable conditions, couldn't those ancient minds achieve extraordinary things? Couldn't small groups, stable and prosperous for a few generations, make intellectual leaps that seem impossible given their context? The footprints at White Sands aren't just evidence of presence. They're evidence of humanity, of families traveling together, children playing in the mud while adults worked nearby, moments of ordinary life preserved accidentally for us to find 21,000 years later. Those people loved and feared and wondered just as we do. They looked up at the stars and asked questions. They watched the sun rise and set and tracked its changing position through the seasons. They felt the pull of the earth on their bodies, noticed that objects fall, that water flows downhill, that certain angles make throwing more effective, that levers multiply force. They lived in the world, and living requires understanding, requires building mental models of how things work, requires learning and teaching and improving. Did they formalize that understanding into laws and equations? Probably not in ways we'd recognize. But did they possess practical, working knowledge of principles we later named and quantified? How could they not? Move through time with me again, hopping forward to the cusp of recorded history, to Sumer and Egypt, to the earliest civilizations we acknowledge. They appear suddenly, startlingly sophisticated, with writing and mathematics and astronomy and architecture seemingly springing fully formed from the dust. The standard explanation involves steady development, argues that we're seeing the culmination of thousands of years of gradual progress, that the earlier stages simply aren't preserved in the archaeological record. Perhaps, but there's another pattern visible if you look for it, a pattern of inheritance, of knowledge claimed to come from earlier, greater times. The Egyptian priests told Herodotus and later Plato that their wisdom derived from times before the Great Flood, from ancestral kingdoms whose records stretched back tens of thousands of years. We dismiss this as mythology, as inflation of chronology to enhance prestige. But what if there's truth mixed with the myth? What if they were remembering, imperfectly but genuinely, civilizations that rose and fell before their own, leaving behind fragments of knowledge that later people puzzled over and incorporated? The flood myths themselves demand attention, not because we believe in a single global deluge, but because they appear in cultures across the globe, separated by oceans and millennia, all describing the same basic event. A time when waters rose and drowned the world, when only a few survived to rebuild. The geological record shows dramatic sea level rise at the end of the last ice age, beginning around 15,000 years ago and continuing for several thousand years, with some particularly rapid pulses. During this period, sea levels rose by over 100 meters, over 300 feet, flooding vast coastal plains, turning peninsulas into islands, erasing entire landscapes beneath the waves. If humans lived in those coastal regions, and we know they did because coasts offer abundant resources, then those populations would have experienced catastrophic displacement, would have watched their world literally drown over generations. Survivors retreating inland would carry stories, would pass down memories of lost lands, lost cities perhaps, lost ways of life. These stories would mutate and merge with mythology, but at their core might lie genuine historical memory of a real climatic catastrophe. What knowledge would be lost in such a collapse? Coastal peoples with access to marine resources would likely have been among the most prosperous, most numerous, most advanced groups of their time. Trade networks along coastlines connect disparate regions, allowing exchange of ideas and technologies. Port cities, if such things existed in that deep past, would have been centers of innovation and learning. If those places drowned, taking their inhabitants and their accumulated wisdom beneath the rising seas, we would be left with only scattered inland groups, survivors who might preserve fragments but lack the full context, the complete understanding. The discontinuity we see in the archaeological record, the apparent sudden emergence of civilization, might actually be reemergence, might be remnant populations slowly rebuilding to levels they or their ancestors had achieved before. This is speculative, admittedly, but it's speculation grounded in the reality of dramatic climate change and its known effects on human populations. Let's anchor this in something concrete, something measurable. The Nazca lines in Peru, those immense geoglyphs etched into the desert floor, some stretching hundreds of meters, depicting animals and geometric shapes visible only from above, created between 500 BCE and 500 CE by the Nazca culture. Their purpose remains debated: ritual pathways, astronomical calendars, water divination maps, all proposed and none fully satisfying. But focus on the engineering, on how they were made. The lines are remarkably straight across irregular terrain, maintaining their orientation for kilometers. Creating such precision requires sophisticated surveying techniques, requires sight lines and measuring tools, requires mathematical planning and execution. The Nazca didn't have aerial views to check their work, yet the proportions remain accurate when seen from the air, suggesting they worked from scaled plans or possessed techniques for laying out large designs from ground level using geometric principles. This is applied mathematics, practical geometry, knowledge of ratios and scaling. The society that created them, while not literate in ways we'd recognize, clearly possessed advanced technical capabilities. Or consider the Polynesian navigators who settled the vast Pacific, traveling thousands of miles across open ocean in double-hulled canoes, reaching isolated islands separated by empty horizons. They navigated without instruments, using observation of stars, wave patterns, cloud formations, bird behavior, using knowledge passed down through generations, encoded in chants and songs and practical training. They understood ocean currents, seasonal winds, the motion of celestial objects, could calculate latitude and longitude using methods that seem intuitive, even mystical, but which rigorous testing has proven accurate and reliable. These were sophisticated oceanographers and astronomers, operating without writing, without metal tools, yet achieving feats of navigation that European sailors with compasses and sextants initially couldn't believe possible. The European mindset, encountering these island peoples, assumed they'd arrived by accident, drifted on currents, never intentionally sailed such distances. This assumption revealed European limitations, not Polynesian ones. The indigenous knowledge was vast, precise, scientific in every meaningful sense, even if not formalized in European ways. Why do we keep returning to this theme, this insistence on recognizing ancient science? Because it's essential to the deeper question we're circling, the question of how long humans have been carefully observing their world, measuring it, building models to explain and predict it. If sophisticated understanding existed in recent prehistory, among Polynesians and Nazca and megalith builders, then why not earlier? Why assume a cutoff, a point before which humans were incapable of such thought? The biological capacity existed, the intelligence and curiosity and pattern recognition abilities that make science possible. The barrier is cultural, technological, the ability to preserve and transmit knowledge. But even that barrier is lower than we often assume. Oral traditions can preserve astonishing amounts of information across countless generations. Aboriginal Australians maintain songs and stories describing landscapes and events that archaeology has confirmed occurred over 10,000 years ago, maintain them accurately enough that modern researchers use them as guides to find ancient sites. Knowledge encoded in story and song and ritual, in the placement of stones and the orientation of structures, can persist far longer than we give it credit for, can bridge the gaps between rises and falls of civilizations. Gravity, to return to our title, to the specific claim that seems most provocative. Did ancient people measure Earth's gravitational acceleration, the 9.8 meters per second squared that governs falling objects? Did they understand it as a force, as an attraction between masses? Almost certainly not in those terms, not using that conceptual framework. But did they observe its effects with precision? Did they incorporate that understanding into their constructions and calculations? Did they develop working models that accounted for gravitational phenomena even if explained through different paradigms? The evidence suggests they might have. The precise angles of megalithic structures, the calculations of astronomers predicting planetary motions, the engineering of aqueducts and irrigation systems requiring exact gradients to maintain flow, all these demonstrate practical understanding of forces and motions, even if the underlying theory differed from ours. Science is fundamentally about predicting outcomes, about building models that work. By that standard, the ancient world was full of scientists, full of careful observers who tested their ideas against reality and refined them across generations. We need to examine more closely what we mean by civilization, by knowledge, by science itself. These words carry assumptions, conjure images of universities and laboratories and published papers, of white coats and peer review and mathematical notation. But strip away the trappings, the institutional structures, and what remains? Curiosity remains. Observation remains. The drive to understand and explain and predict remains. These are human universals, found in every culture, every time period. A Paleolithic hunter predicting animal behavior based on tracking experience is doing science. A Neolithic farmer selecting seeds from the best plants year after year, improving crop yields through applied genetics before genes were known, is doing science. A Bronze Age metallurgist experimenting with or ratios and furnace temperatures to produce better bronze is doing science. The method is the same. Observe, hypothesize, test, refine. The sophistication varies, the tools vary, the conceptual frameworks vary, but the fundamental process of systematic inquiry is constant across human experience. What we're confronting here is a form of temporal provincialism, an assumption that our moment in history is uniquely enlightened, that we've finally escaped the darkness of superstition and ignorance that characterized all previous ages. This is comforting, flattering even, but it's demonstrably false. People in every age believe themselves enlightened relative to their predecessors. The Romans looked back at the Greeks as the true philosophers, while dismissing pre-classical peoples as barbarians. The Greeks claimed Egypt as the source of ancient wisdom. The Egyptians pointed further back, to times before the flood, to gods who walked the earth as men. Each generation stands on the shoulders of giants while declaring itself the first to truly see. Perhaps it's time to admit that the giants go deeper than we thought, that the shoulders we stand on rest on earlier shoulders, stretching back into a past more complex and accomplished than our models allow. Let's examine a case study that brings these themes together, that demonstrates ancient technical capability in ways difficult to dismiss. The Inca road system, spanning over 40,000 kilometers across some of the world's most challenging terrain, mountains and deserts and jungles, built without the wheel, without iron tools, without written language to coordinate the effort. The roads themselves are engineering marvels, carved into cliff faces, built up over ravines with precisely fitted stone, designed with drainage systems and steps and rest houses at calculated intervals. They demonstrate understanding of grade and distance, of logistics and organization, of geology and material properties. But more impressive are the bridges, particularly the suspension bridges woven from grass rope, spanning river gorges hundreds of feet across. These bridges had to be rebuilt annually as the rope degraded, an enormous labor investment. Yet the Inca maintained hundreds of them across the empire because they were essential to communication and control. The engineering knowledge required to design a suspension bridge is substantial. Calculating weight distribution, tension in cables, safe load limits, the geometry of catenary curves. The Inca had this knowledge, proven by the fact that their bridges worked, that they safely carried traffic for centuries. They didn't write equations, didn't formalize the mathematics in ways we'd recognize, but they solved the same problems through observation and experimentation and accumulated experience. This pattern repeats across the ancient world. The Roman concrete that has outlasted modern concrete, still standing in structures 2,000 years old while modern buildings crumble after decades, incorporated volcanic ash in precisely calculated ratios that produce a material more durable than what we typically use. The recipe was lost after Rome's fall, only recently rediscovered through chemical analysis of ancient structures. Roman engineers knew, through trial and observation, what ratios worked best, what additives enhanced particular properties, knowledge that took us centuries to regain. The Damascus steel I mentioned earlier, with its distinctive wavy patterns and legendary sharpness, incorporated carbon nanotubes in its structure, microscopic features we couldn't even see until electron microscopy, yet medieval smiths created them consistently through careful control of forging temperature and technique. They didn't know about nanotubes, didn't understand the chemistry at atomic levels, but they knew their process worked, knew how to achieve desired results, built working knowledge through generations of practice and refinement. Now push this pattern back further, into the Stone Age, into periods where the evidence becomes fragmentary and contested. Is it really so implausible that some Paleolithic groups, stable and prosperous for a few generations, made similar advances in their contexts, achieved sophisticated understandings in domains relevant to their lives? They wouldn't have metallurgy, wouldn't have writing, but they would have tools and materials available to them, would have phenomena they could observe and manipulate. The acoustics of caves, the properties of pigments and binders, the fracture mechanics of stone, the behavior of wild animals, the patterns of stars and seasons, all these domains offered opportunities for systematic study and accumulated knowledge. Some of that knowledge would be lost as groups migrated or collapsed or were absorbed by others. Some would persist, encoded in practices and traditions, foundations for later rediscovery. The genetic evidence adds layers to this picture, suggests population movements and mixings far more complex than we initially imagined. Modern humans didn't simply replace earlier hominins, didn't sweep across the world leaving extinction in their wake. We interbred with Neanderthals, with Denisovans, probably with other archaic populations we haven't yet identified. These weren't mindless beasts, they were intelligent beings with their own cultures, their own accumulated knowledge. When populations mixed, knowledge mixed. Ideas and techniques would have been exchanged, compared, incorporated or discarded based on utility. This process has been going on for hundreds of thousands of years, longer than we have clear records, longer than we can easily comprehend. How much has been learned and forgotten and relearned in that vast expanse of time? How many cycles of advancement and collapse have occurred, leaving only the faintest traces for us to puzzle over? There's a tendency in modern thought to view history as a simple upward trajectory, an arrow pointing from primitive past to enlightened present to utopian future. This narrative comforts us, reassures us that whatever our problems, we're moving in the right direction, that progress is inevitable and continuous. But the actual pattern of human history is far more complex, far more cyclical. Civilizations rise and fall. Knowledge accumulates and dissipates. Technologies emerge and are forgotten. The library at Alexandria burned, taking with it countless works of ancient science and philosophy that will never recover. The Roman Empire collapsed, plunging Europe into centuries where literacy declined, where technical capabilities atrophied, where knowledge preserved in monasteries survived only by chance and dedicated effort. The Mayan civilization, with its sophisticated writing and mathematics and astronomy, collapsed across the 9th century, its cities abandoned, its knowledge largely lost until modern scholars painstakingly reconstructed it from fragmentary inscriptions. These aren't ancient anomalies, they're the pattern. Progress is not guaranteed. Knowledge is fragile. What one generation builds, the next can lose. If this can happen in historical periods, with writing and institutions and dense populations, how much more easily could it happen in prehistory? A talented group develops sophisticated techniques for working stone, for predicting game movements, for navigating by stars. They prosper, passing knowledge to their children for several generations. Then climate shifts, game disappears, they're forced to migrate into new territory where their specialized knowledge is less applicable. Within a few generations, as older members die and immediate survival concerns dominate, the subtle techniques are lost, simplified, forgotten. Later peoples in the same region might find evidence of the earlier group's work, might puzzle over artifacts that seem too advanced, might incorporate some findings into their own practices without understanding the full context. This is how knowledge erodes, how capabilities can appear and vanish from the archaeological record, leaving us with anomalies and mysteries. But there's another possibility we should consider, one more optimistic perhaps, or more unsettling depending on your perspective. What if knowledge doesn't simply accumulate linearly but rather oscillates, rises to certain levels, falls back, rises again, tracing a pattern that over very long timescales might trend upward but which in shorter spans can show dramatic variation. What if humans have repeatedly approached levels of sophistication we'd recognize as advanced, not our level, certainly not industrialized technological civilization, but nevertheless far beyond what we credit them with, only to have those advances disrupted by catastrophe, by climate change or disease or warfare or simple cultural collapse? The evidence we've examined, the anomalously early tools, the sophisticated ancient engineering, the astronomical knowledge predating supposed civilization, all this fits a pattern of repeated achievement and loss, of human potential expressing itself whenever conditions allow and then being pruned back by the harsh realities of existence in an unstable world. Consider the Younger Dryas event, a sudden climatic reversal that occurred about 12,800 years ago, right at the end of the last ice age when warming was well underway. Temperatures plummeted again, glaciers re-advanced. The warming trend interrupted for over 1,000 years before resuming. The cause is still debated. Proposed mechanisms include disruption of ocean currents by glacial meltwater, volcanic eruptions, even a comet impact breaking up over North America, triggering wildfires and ejecting debris that cooled the atmosphere. Whatever the cause, the effects on human populations would have been catastrophic. Groups that had adapted to warming conditions, that had expanded into newly hospitable territories, would have faced sudden collapse of food sources, forced migrations, population crashes. If sophisticated cultures existed at the transition between Ice Age and current climate, the Younger Dryas would have devastated them, erased much of their material culture, scattered survivors into marginal regions. When warming resumed and populations recovered, they might carry only fragments of earlier knowledge, might remember old ways imperfectly, might have to rebuild from a dramatically reduced baseline. This isn't pure speculation, there's archaeological evidence of human responses to the Younger Dryas. The Natufian culture in the Levant, which had begun experimenting with cultivation of wild grains, appears to have abandoned sedentary life and returned to mobile hunting and gathering as conditions deteriorated, only resuming agriculture later when climate stabilized. Göbekli Tepe, that mysterious site we mentioned earlier, was built shortly after the Younger Dryas ended, its construction perhaps representing a re-emergence of organizational capability and astronomical knowledge after the disruption. The site was deliberately buried about 1,000 years after its construction, stones carefully covered with earth, reasons unknown. Was this preservation, an attempt to protect sacred knowledge from some perceived threat? Or abandonment, a culture moving on from old practices? We don't know. We're left with monuments and artifacts that ask more questions than they answer, with evidence that human capabilities in deep prehistory exceeded what simple models predict. Let's bring this back to the individual, to the personal scale, because these vast timescapes and abstract discussions of lost civilizations can feel disconnected from human reality. Think about what you personally know, what skills you possess. How many of them could you actually teach to someone else with no prior context? How much of your daily functionality depends on systems and knowledge you don't fully understand? You use a smartphone without comprehending the semiconductor physics that makes it function. You drive a car without being able to repair its engine or electronic systems. You rely on electrical grids, water treatment plants, global supply chains, all operating on principles you might vaguely grasp but couldn't reproduce. If civilization collapsed tomorrow, if you were suddenly thrown into a survival situation with a small group, how much of modernity could you recreate? How quickly would knowledge erode, even in your own mind, as immediate concerns overwhelmed abstract understanding? This thought experiment illuminates the fragility of cultural knowledge, shows how quickly we could lose capabilities we take for granted. Now imagine this process playing out over generations, each one a bit more removed from the high point of knowledge, each one losing a bit more, adapting to simpler circumstances. Within a few centuries, descendants might possess only garbled memories of what their ancestors achieved, might worship the artifacts they find as products of gods or giants, unable to conceive that ordinary humans like themselves created such things. This is how Polynesian islanders, descended from master navigators, sometimes forgot the art of building ocean-going canoes after generations on small isolated islands where such vessels were unnecessary. This is how medieval Europeans looked at Roman ruins and attributed them to mythical past races, unable to believe their own ancestors built such structures. Knowledge atrophies without use, without transmission, without the cultural context that makes it relevant and valued. But knowledge also persists in unexpected ways, encoded in language, in customs, in the landscape itself. Indigenous place names often preserve information about the land, about water sources or seasonal resources or historical events. Fairy tales and folk stories sometimes contain garbled memories of real phenomena, real historical occurrences distorted through countless retellings. The story of Atlantis, related by Plato as something he heard third-hand from Egyptian priests, might be mythologized memory of actual Bronze Age civilizations destroyed by volcanic eruptions or sea level rise. The biblical flood narratives, the Mesopotamian Gilgamesh epic, the Manu legends in India, all describing deluge and survival, might encode genuine memories of post-glacial flooding events. We can't simply dismiss traditional knowledge as superstition and myth, can't assume that because the framing is supernatural the content is necessarily false. Careful analysis of oral traditions, compared against archaeological and geological evidence, has repeatedly revealed historical cores within mythological shells. This brings us to an uncomfortable realization. Much of what we think we know about human prehistory is based on absence of evidence rather than evidence of absence. We haven't found widespread sophisticated tool use before a certain date, so we assume it didn't exist. We haven't excavated cities predating Sumer, so we declare them the first civilization. But absence of evidence is weak argument when the evidence we're looking for is inherently difficult to preserve and easy to miss. Organic materials, wood and fiber and leather that would have comprised most ancient tools and structures, decay completely in most environments. Only stone and occasionally bone survives the millennia. If a Paleolithic culture worked primarily in wood, built sophisticated structures and tools from perishable materials, they'd leave almost no archaeological trace. Their existence would be invisible to us unless we happen to find preserved remains in extraordinary circumstances, in peat bogs or ice or underwater sites sealed away from oxygen and decay. Moreover, we've explored only a tiny fraction of potential archaeological sites. Most ancient coastlines, where humans preferentially settled due to abundant resources, now lie under hundreds of feet of ocean, inundated by post-glacial sea level rise. Underwater archaeology is difficult, expensive, limited in scope. We've surveyed perhaps a tiny percentage of the drowned continental shelves, found a handful of sites preserving evidence of submerged human occupation. What lies undiscovered in those vast underwater regions? Remains of coastal settlements that might challenge our chronologies and assumptions. We don't know. We can't know until we look systematically, and even then, the evidence might be degraded beyond recognition, scattered by thousands of years of currents and sediment deposition. Our ignorance is vast, and we should hold our conclusions lightly, provisionally, ready to revise when new evidence emerges. Let's examine one more specific example before we begin synthesizing these threads, one more anomaly that demands explanation. The Piri Reis map, created in 1513 by an Ottoman admiral, shows the Atlantic coast of South America with remarkable accuracy considering the date, shortly after Columbus. But more intriguingly, it appears to show the Antarctic coastline, and not the ice-covered coastline we know today but rather the underlying topology, the shape of the land beneath the ice. Critics argue the southern portion depicts Patagonia, distorted by imperfect information, not Antarctica at all. Proponents argue that some of the features match Antarctic coastal features confirmed only through modern seismic surveys penetrating the ice. Piri Reis himself claimed his map was compiled from earlier sources, some ancient, some contemporary. If there's any truth to the Antarctic interpretation, it implies either that the coastline was mapped before glaciation, which would push the date back many thousands of years to the last time that region was ice-free, or that information about the subice topology existed through some unknown means and was preserved in map traditions that Piri Reis accessed. The controversy around this map illustrates the challenges of interpreting anomalous evidence. It's easy to dismiss, easy to explain away as misinterpretation or coincidence or fraud. But it's equally easy to overinterpret, to see confirmation of pet theories rather than acknowledging ambiguity. The truth likely lies in nuanced middle ground. Yes, ancient mariners explored more extensively than we often credit. Yes, information could be preserved in navigational traditions and copied maps for generations. Whether that information includes genuine knowledge of Antarctic geography is much less certain. Requires extraordinary evidence given the extraordinary claim. But the map remains tantalizing, suggestive of knowledge transmission across vast time spans, even if we can't definitively prove the most dramatic interpretations. This is the position we find ourselves in repeatedly when examining deep history, standing between competing explanations, unable to prove definitively which is correct, forced to weight probabilities and make judgments based on incomplete information. It's uncomfortable for those seeking certainty, seeking clear answers to questions about our origins and capabilities. But it's also thrilling because it means the story isn't finished, the investigation continues, and any of us might encounter the evidence that shifts the paradigm, that forces reconsideration of what we thought we knew. This is science at its best, not dogmatic assertion but genuine inquiry, willingness to follow evidence even when it leads to unsettling conclusions. So what does all this evidence, fragmentary and contested as it is, tell us when we step back and examine the pattern as a whole? It tells us that human history is deeper, stranger, more complex than the simplified narratives we teach in schools. It tells us that our ancestors, across vast spans of time, were far more capable than we generally acknowledge, that the potential for sophisticated observation and logical deduction and technical achievement has existed as long as modern human cognition has existed. It tells us that knowledge is fragile, that civilizations can rise and fall leaving barely a trace, that what one age accomplishes another can lose entirely. And it suggests, provocatively, that we might not be the first human society to look up at the stars and wonder, to measure and calculate and try to understand the forces that govern our world. We might be the latest in a long series of such awakenings, each building on fragments of what came before, each contributing to a collective human project that spans far longer than recorded history. This realization should humble us, should puncture any notion that our moment is uniquely enlightened, that we've finally escaped the ignorance of the past. But it should also inspire us, should connect us to that vast human project, make us feel part of something much larger than our individual lives or even our entire civilization. Every question we ask, every mystery we investigate, every piece of knowledge we add to the collective understanding, we're doing what our ancestors did, what humans have always done, what defines us as a species. We're curious. We're pattern seekers. We're toolmakers and storytellers and measurers of the world. That impulse drove someone 23,000 years ago to walk across wet sand in New Mexico, drove someone 32,000 years ago to mix pigments and paint bison on a cave wall in France, drove someone hundreds of thousands of years ago to carefully shape a stone into a tool and carry it across landscapes we can only imagine. That same impulse drives us now, sends our robots to Mars, our probes to the edge of the solar system, our questions into the deepest puzzles of existence. But let's return specifically to gravity, to the claim in our title, because we've circled around it without addressing it directly. Did ancient people measure Earth's gravity before Newton formulated his laws in the 17th century? In the strictest sense, in terms of calculating the gravitational constant and understanding gravity as a universal force between all masses, almost certainly not. That required specific conceptual frameworks and mathematical tools that we have no evidence ancient peoples possessed. But did they observe and measure gravitational effects? Did they incorporate practical understanding of weight and fall and trajectory into their engineering and astronomy? Unquestionably, yes. Did some groups achieve levels of precision in those measurements and calculations that we find surprising given their technological context? The evidence suggests they might have. The megalithic builders who created precisely aligned monuments were measuring angles and distances with sophisticated surveying techniques that necessarily involve leveling instruments, plumb lines, careful observation of stars at specific moments. A plumb line is responding to gravity, hanging straight down toward Earth's center. Use it carefully enough, and you're measuring gravitational vertical with precision. The pyramid builders achieved orientation and leveling accuracy that challenges modern construction, the Great Pyramid's base level to within fractions of an inch over a length of hundreds of feet. This requires understanding and correcting for slight variations in the gravitational field, requires instruments and techniques that factor in Earth's shape and the local gravitational environment. Did they conceptualize it as measuring gravity? Probably not. Did they have working methods that effectively accomplished the same practical goals? The evidence of their achievements suggests they did. Ancient astronomers predicting planetary positions needed to account for gravitational effects, even if they didn't recognize them as such. The irregularities in lunar and planetary orbits, the precession of Earth's axis, the tides correlating with moon phases, all these phenomena are gravitational in nature, all require sophisticated observation and mathematical modeling to predict accurately. The fact that Babylonian astronomers could predict eclipses centuries in advance means they had working models of celestial mechanics that, while framed in different conceptual terms, successfully captured gravitational realities. They weren't measuring gravity directly, but they were measuring its effects and building predictive models, which is essentially what physicists do today, just with different tools and frameworks. Perhaps the most direct evidence comes from ancient weights and measures, from the standardization we see across cultures of specific units related to physical properties of water and earth. A liter of water weighs 1 kilogram because we define those units to relate in that way, but ancient systems show similar relationships, suggesting that they were deriving measurement standards from physical constants, from the behavior of materials under gravity's influence. The Egyptian royal cubit relates to dimensions of Earth and to the period of pendulums at specific latitudes in ways that seem too precise to be accidental. The Sumerian sexagesimal system, base 60 mathematics, enables calculations of circles and angles with elegant efficiency, relates to astronomical cycles in ways that suggest it was developed specifically for calendrical and navigational purposes. These systems represent accumulated knowledge, refined over generations, encoding understanding of the world in purely practical terms but understanding nonetheless. What emerges from all this examination is a picture not of ignorant savages stumbling through their world, not of civilization suddenly igniting 6,000 years ago after hundreds of thousands of years of stagnation, but rather of human intelligence expressing itself continuously across our entire existence as a species, achieving different things in different contexts, sometimes accumulating to levels we'd recognize as sophisticated, sometimes falling back to basics under pressure of climate or conflict or catastrophe, but always observing, always trying to make sense of the world, always measuring and calculating and building mental models to explain and predict. The forms change, the conceptual frameworks evolve, the tools improve or deteriorate depending on circumstances, but the fundamental human drive to understand remains constant. We are measurers. We've always been measurers. Before we had rulers, we used body parts, paces, shadows. Before we had clocks, we used sun and stars and seasons. Before we had theories of universal gravitation, we watched things fall and learned to predict where they'd land. This is not to claim ancient peoples had modern science, that they somehow anticipated Einstein or built computers or visited the moon. They didn't. But they were doing science in the fundamental sense of systematic observation and model building and testing predictions against reality. They were applying intelligence and curiosity to the world around them, accumulating knowledge within the constraints of their circumstances. To dismiss this, to insist that real knowledge began with Aristotle or Galileo or whoever we choose as our starting point, is to misunderstand what knowledge is to confuse the formalization and documentation of understanding with the understanding itself. A child who learns that objects fall and heavier objects are harder to lift has practical gravitational knowledge, even if she doesn't know the word gravity, even if she has no mathematical equation describing the phenomenon. The knowledge is real, functional, applicable. Scale that up across generations of careful observers, and you get increasingly sophisticated working understanding of physical principles, understanding that might never be formalized in treatises but which nevertheless guides practical achievements. We've covered vast ground in this exploration, jumped across continents and millennia, examined tools and footprints and structures and maps and myths. Let's try to synthesize, to draw the threads together into something coherent, something that honors the complexity without drowning in it. The story that emerges is one of human capability far deeper in time than conventional narratives acknowledge. It's a story of repeated achievement and loss, of knowledge rising and falling across cycles we can barely perceive, of catastrophes, climate changes, and collapses erasing hard-won understanding that later generations must rebuild. It's a story that places our current moment not as the culmination of a linear progression from ignorance to enlightenment but rather as one more chapter in a much longer story. A chapter where we've achieved certain capabilities but have also lost connections to deep wisdom that earlier peoples possessed. This perspective should make us both proud and humble. Proud of our ancestors, who survived unimaginable hardships and still found time and energy to observe their world, carefully, to create beauty, to pass on knowledge, to build structures that endure millennia later. Proud of ourselves, inheritors of that long tradition, still pushing at the boundaries of understanding, still asking questions no one has answered. But humble too, recognizing how much we've lost, how fragile our own knowledge base is, how quickly we could lose capabilities we take for granted. Humble in the face of mysteries we still can't explain, of artifacts and structures that challenge our assumptions, of evidence that refuses to fit comfortably into our models. This balance between pride and humility, between confidence in human potential and recognition of human limitations, seems like the appropriate stance when examining our deep past. What practical implications does this have for how we approach archaeology and anthropology going forward? First, it suggests we need to hold our models more lightly, be more willing to revise when new evidence emerges, resist the temptation to dismiss anomalies simply because they're inconvenient. The history of science is full of instances where anomalies pointed toward new understanding, where data that didn't fit the prevailing theory eventually forced paradigm shifts. We should treat archaeological anomalies the same way, investigate them rigorously rather than explaining them away. Second, it argues for more exploration in neglected areas, particularly underwater sites and tropical regions where preservation is poor and excavation difficult, but where human populations were likely concentrated. We're missing huge portions of the human story because we've focused research in temperate regions with good preservation and easy access. Third, it suggests we should pay more attention to traditional knowledge, oral histories, and indigenous perspectives on the past, not accepting them uncritically but recognizing they may contain genuine historical information worth investigating. Most fundamentally, perhaps, this perspective asks us to extend to ancient peoples the same courtesy we'd want extended to ourselves. The assumption of intelligence, capability, creativity. When we encounter something that seems too advanced for its context, the first question shouldn't be, how can we explain this away? But rather, what does this tell us about the people who made it? If they achieved something impressive, give them credit for that achievement, try to understand their methods rather than assuming they couldn't possibly have done it without help from lost civilizations or ancient aliens or whatever explanatory crutch we reach for to avoid acknowledging ancient human capability. Our ancestors were as smart as we are. They observed their world as carefully as we observe ours. They solved problems with the tools available to them. Respect that. Learn from it. There's something deeply satisfying about this recognition, something that connects us across the vast gulf of time. When you watch the sun rise, you're seeing the same sun they saw, moving along the same path, marking the same seasonal changes. When you feel the pull of gravity, feel your weight against the earth, you're experiencing the same force they felt, the force that governed their lives as it governs ours. When you wonder about existence, about where we came from and where we're going, you're asking questions they asked, questions that echo down through generations, questions that define what it means to be human. We're linked to them not just by DNA, not just by the physical continuity of reproduction, but by shared experience, shared curiosity, shared drive to understand. They measured the world with the tools they had. We measure it with different tools. But we're engaged in the same essential project, the human project of making sense of existence. And so we return to where we began, standing in that cave, in that darkness that has held its secrets for countless centuries. The walls remember pigments applied by hands long turned to dust. The ground preserves footprints of children who played here when glaciers still covered continents to the north. The tools scattered in the sediments ask their patient question. Who made us and what did they know? We still don't have complete answers. We likely never will because the evidence is too fragmentary, the gaps too vast, the losses too profound. But we know more than we did. We know our ancestors were capable and curious. We know they observed their world carefully and built working understanding of its patterns. We know they sometimes achieve things that surprise us, that challenge our assumptions, that force us to reconsider our place in the long story of human existence. Perhaps that's enough. Perhaps the point isn't to definitively answer every question, to reconstruct complete narratives from incomplete evidence, but rather to maintain the inquiry itself, to keep asking and searching and remaining open to possibilities. The mystery is part of the value. The uncertainty keeps us humble, keeps us questioning, prevents the ossification of knowledge into dogma. Every generation discovers something that previous generations missed, reinterprets evidence through new lenses, adds pieces to a puzzle that will never be fully completed because new pieces keep emerging from the earth. This is as it should be. History is not a static thing, carved in stone and unchangeable, but a living discipline, constantly revising its understanding as new information comes to light. Think about what future archaeologists might conclude about our civilization if they excavated our remains thousands of years from now, after some collapse we can't yet imagine. Most of what we consider essential would be gone, decayed, corroded, unrecognizable. Our electronics would be meaningless lumps of oxidized metals and degraded plastics. Our buildings would be rubble, foundations, and occasional walls, all that survived. Our written records, mostly digital now, would be completely lost, unreadable without the specific technologies we use to encode and display them. They might find scattered artifacts, might puzzle over purposes and meanings, might dramatically underestimate our capabilities based on the fragmentary remains. And they'd be wrong, not because they were foolish but because preservation is selective, because time destroys most of what we create, because inferring a complete picture from scattered remnants is inherently difficult and error-prone. This is the situation we face when studying deep prehistory, only magnified by the much greater time spans involved and the much more limited material culture of ancient peoples. We're trying to reconstruct entire ways of life from a few stone tools, some bones, occasional structures that survived only because they were built massively in stone or were preserved under exceptional circumstances. It's like trying to understand a novel when you have only a few randomly selected pages, trying to see a mosaic when most of the tiles are missing. We can make educated guesses, can build models that fit the available evidence, but we should hold those models with appropriate tentativeness, recognizing how much we're inferring from how little remains. Yet despite these limitations, despite the vast gaps in our knowledge, a picture does emerge from the accumulated evidence. A picture of human beings who have been essentially unchanged in capacity for tens of thousands of years, who have repeatedly demonstrated sophistication and ingenuity within their circumstances, who have measured and calculated and wondered about their world in ways we're only beginning to appreciate. The evidence is there, in the precisely aligned megalithic structures, in the ancient astronomical calculations, in the sophisticated tool industries, in the cave art and symbolic artifacts that demonstrate abstract thought and cultural complexity. It's there in the DNA that reveals complex migration patterns and extinct lineages, in the geological evidence of past climates and catastrophes that shaped human populations. It's there in the oral traditions and myths that preserve garbled memories of real events. We just have to look carefully, have to be willing to question our assumptions, have to extend to ancient peoples the credit they deserve. This brings us to perhaps the most important question of all, the question that underlies this entire inquiry. Why does it matter? Why should we care whether ancient peoples measured gravity or built sophisticated structures or possessed knowledge we didn't credit them with? What practical difference does it make to our lives today whether the human story extends back further than we thought, whether capabilities existed earlier than conventional timelines suggest? On one level, perhaps it doesn't matter practically. Our daily lives continue regardless of how we understand prehistory. But on another level, a deeper level, it matters profoundly. It matters because how we understand our past shapes how we understand ourselves, shapes our sense of who we are and what we're capable of, shapes our relationship to knowledge and to each other and to the future we're building. If we believe we're the first truly advanced human society, if we see all previous ages as darkness from which only we have emerged into light, then we'll feel no connection to that past, we'll see no need to learn from it, we'll repeat mistakes that earlier peoples already made and paid for. But if we recognize that human intelligence has been expressing itself across our entire existence as a species, that earlier peoples achieved remarkable things within their contexts, that knowledge has risen and fallen multiple times across the vast span of human time, then we gain perspective. We see ourselves as part of a longer story, inheritors of both achievements and losses, responsible for preserving and advancing what we've been given, aware that what we take for granted could be lost if we're not careful. This awareness becomes particularly relevant as we face challenges that earlier peoples also faced: climate change, resource depletion, conflict over territory and ideology, the tension between short-term survival and long-term sustainability. They survived those challenges, navigated them with varying degrees of success, sometimes thrived and sometimes collapsed under the pressure. We can learn from their experiences, can study how they adapted or failed to adapt, can apply those lessons to our own circumstances. But we can only do that if we take them seriously, if we study them carefully, if we recognize them as intelligent beings grappling with real problems rather than dismissing them as primitive precursors to our supposed enlightenment. There's also something spiritually or philosophically important about recognizing our connection to deep human time. We live in an age of rapid change, of constant novelty, where everything seems to be happening for the first time. This can be exciting but also disorienting, can leave us feeling unanchored, disconnected from any sense of continuity or larger meaning. Understanding that we're part of a story that stretches back tens of thousands of years, that the questions we ask and the challenges we face echo questions and challenges that humans have always confronted, provides perspective and grounding. We're not alone, adrift in an incomprehensible present. We're connected to everyone who came before, to their struggles and achievements, to their observations and insights. That connection is real, tangible, coded in our DNA and our cultural inheritance and the very structure of the world we inhabit, shaped by countless generations of human activity. So when you look up at the stars tonight, remember that you're seeing what your ancestors saw, that they wondered about those same lights, tracked their movements, built their own models to explain and predict what they observed. When you pick up a stone and feel its weight, remember that someone tens of thousands of years ago felt that same weight, understood through experience and observation how it would fall, how it could be shaped and used, how it participated in the fundamental forces governing the world. You're connected to them, separated by time but united by experience, by curiosity, by the human drive to understand. This connection should matter to you, should inform how you see yourself and your place in the vast sweep of human existence. We've explored the evidence for ancient human capability across multiple domains: toolmaking, navigation, astronomy, engineering, art, symbolic thought. We've examined specific anomalies that challenge conventional chronologies. Tools in impossibly old strata, footprints predating supposed first arrivals, genetic signals pointing to complex migration patterns, structures demonstrating sophisticated knowledge. We've considered how knowledge can be lost through catastrophe and cultural collapse, how oral traditions preserve information across vast time spans, how absence of evidence differs from evidence of absence. And we've returned repeatedly to the theme of measurement, of humans observing their world carefully and building working understanding of its patterns and forces, including gravitational effects even if not conceptualized in modern terms. The title promised a civilization that measured Earth's gravity before science existed, and we've delivered on that promise, though perhaps not in the way you initially expected. Not a single lost supercivilization with technologies matching our own, not ancient aliens or Atlantean empires, but something more subtle and more profound. The recognition that human intelligence and curiosity have been operating across our entire existence as a species, that careful observation and practical understanding of physical forces, including gravity, predates formal science by tens of thousands of years. The farmer understanding that water flows downhill is working with gravity. The hunter calculating trajectories is modeling gravitational effects. The megalith builder ensuring level foundations is measuring gravitational vertical. These aren't modern physicists, but they're doing physics in the fundamental sense of studying and applying natural laws. They're measuring their world and building useful models of how it works. That they didn't write equations or formulate universal theories doesn't diminish their achievements, doesn't mean their knowledge was any less real or applicable. This broader definition of knowledge, this recognition that understanding can exist without formalization, that science at its core is systematic observation and model building rather than laboratories and peer review, opens vast new territory for investigation. It allows us to look at ancient peoples as potential sources of insight rather than merely objects of study, allows us to consider that they might have observed things we've missed, understood things we're still learning. There are documented cases of this, instances where indigenous knowledge proved accurate against scientific skepticism. Aboriginal Australians described extinct megafauna accurately enough that researchers used their traditions as guides to paleontological discoveries. Polynesian navigational techniques, dismissed as impossible by European sailors, proved sophisticated and effective when finally studied seriously. Traditional medicine, often derided as superstition, has yielded numerous pharmaceutical compounds when investigated scientifically. The pattern suggests that we should approach traditional knowledge with respect and curiosity, mining it for insights while subjecting claims to rigorous testing. We should extend the same approach to ancient knowledge more broadly, to the evidence preserved in structures and artifacts and practices. What can we learn from megalithic builders about astronomy and geometry? What do traditional cultivation practices teach us about ecology and sustainable land management? What insights into human psychology and social organization are embedded in ancient rituals and stories? These aren't idle academic questions, they have practical relevance for how we organize our own society, how we relate to the environment, how we preserve and transmit knowledge across generations. The past is not just prologue. It's a vast repository of human experience and experiment, of solutions tried and lessons learned, available to us if we're willing to study it carefully and humbly. As we approach the end of this exploration, I want to acknowledge the speculative nature of some of what we've discussed. Not everything presented here is settled fact, accepted by all researchers. Some of the evidence is controversial, some of the interpretations contested. This is appropriate and necessary. Science advances through debate, through proposing hypotheses and testing them rigorously, through skepticism that demands strong evidence for extraordinary claims. I've tried to be clear about what's well-established and what's more speculative, tried to present alternative explanations where they exist, tried to avoid the trap of cherry-picking evidence to support predetermined conclusions. But I've also tried to make the case that conventional models have their own assumptions and limitations, that the absence of evidence for earlier human capability is partly a function of where and how we've looked, that we should remain open to revising our understanding as new evidence emerges. The mystery of human origins, of our deep past, will likely never be completely solved. There are limits to what archaeology can recover, limits to what we can infer from fragmentary remains, fundamental uncertainties that no amount of research can eliminate. But that doesn't mean the inquiry is futile, doesn't mean we should stop asking questions or resign ourselves to ignorance. Every discovery adds to our understanding. Every new technique opens new avenues of investigation. Every generation reinterprets the evidence and comes to new insights. The process is ongoing, dynamic, alive with possibility. We're privileged to participate in it, to contribute however modestly to the collective human project of understanding ourselves and our past. And so the question lingers, suspended in the darkness of deep time, echoing across the millennia. What did our ancestors know? What did they measure and calculate and understand in their own ways, using their own frameworks? How much have we lost and rediscovered? How much remains lost? How much do we assume is new that is actually very old? These questions don't have simple answers. They invite contemplation, invite each of us to look at the evidence and form our own conclusions, to participate in the inquiry rather than passively accepting what we're told. That's the gift of mystery, the value of uncertainty. It keeps us engaged, keeps us thinking, keeps us humble before the vast unknown that surrounds the small islands of our knowledge. Before we close, I want to draw your attention one more time to the sheer scale of what we're discussing. Modern humans, anatomically and cognitively like us, have existed for at least 200,000 years, perhaps 300,000 years depending on how we define the boundaries. Written history extends back maybe 5,000 years. That means we have direct written records for less than 2% of the time modern humans have existed. 98% of the human story is prehistoric, accessible only through archaeology, genetics, and the fragmentary oral traditions that have survived. That's an enormous gap, a vast dark ocean of time with only occasional islands of evidence breaking the surface. To assume we understand what happened in that expanse based on the tiny fraction we can directly observe is hubris of the highest order. Consider what could happen and be completely lost in that time span. Entire languages could develop, flourish, and go extinct without leaving a trace. Technologies could be invented and forgotten multiple times. Civilizations could rise to modest heights and collapse utterly. Their remains eroded or buried or recycled by later peoples. Knowledge could accumulate over thousands of years and then be lost in a single generation due to disease or warfare or natural catastrophe. The archaeological record is like a book with 98% of its pages torn out, scattered to the wind, degraded beyond recovery. We're trying to reconstruct the plot from the few surviving fragments, and while we can make educated guesses, we should admit that much remains uncertain, ambiguous, open to multiple interpretations. This uncertainty is uncomfortable for modern sensibilities trained to expect definite answers, clear facts, settled science. But it's also honest, appropriate to the actual state of our knowledge. The history of archaeology and paleoanthropology is full of confident assertions later overturned by new evidence, of paradigms that seemed unshakable until they suddenly shifted, of consensus views that proved wrong when new techniques or discoveries forced reconsideration. The Clovis first model of American colonization, taught as established fact for decades, has been progressively undermined by pre-Clovis sites that can no longer be dismissed. The view of Neanderthals as evolutionary dead ends has been completely revised by genetic evidence showing they interbred with modern humans and contributed to our genome. The timeline for human evolution in Africa keeps being pushed back as new fossils are found. We're constantly learning that things are older, more complex, more interconnected than we thought. This pattern should make us cautious about declaring anything definitely settled, should keep us open to possibilities we haven't yet imagined. What would it take to definitively prove or disprove some of the more controversial claims we've discussed? For the anomalously old tools, we'd need multiple sites with clear stratigraphy and concordant dates from different methods, dates that couldn't be explained away as contamination or disturbance. We'd need evidence of human presence in the form of not just tools but fossils, hearths, clear living structures, accumulated over time in ways that demonstrate sustained occupation rather than isolated anomalies. For ancient advanced knowledge, we'd need clearer evidence of how that knowledge was developed and transmitted, need artifacts or inscriptions that demonstrate mathematical or scientific principles explicitly rather than ambiguously. For lost civilizations predating Sumer, we'd need actual settlements, architectural remains, clear material culture, evidence that couldn't be explained as isolated developments. The bar is rightly high for extraordinary claims, and most of what we've discussed doesn't yet meet that bar. But it's also true that we haven't looked everywhere, haven't explored systematically the places most likely to yield such evidence, haven't applied all available techniques to all potentially relevant sites. The future of this inquiry lies in new technologies and new exploration. Ground-penetrating radar and LiDAR surveys can detect buried or obscured structures without excavation, have already revealed extensive ancient settlements previously unknown. Genetic techniques keep improving, allowing us to extract and analyze DNA from ever-older samples, revealing population movements and mixtures we couldn't previously detect. Dating methods become more precise, able to resolve finer chronological distinctions, less subject to contamination and error. Underwater archaeology expands as diving and remote sensing technologies improve, opening access to the drowned landscapes where much of the human story might be preserved. Each of these advances will add new data, will force refinement of our models, will answer some questions while inevitably raising new ones. But technology alone won't resolve these mysteries. We also need changes in mindset, need to approach the past with appropriate humility and openness, need to resist the temptation to force evidence into predetermined frameworks. We need to fund and encourage exploration in neglected areas and time periods, need to take seriously the anomalies and outliers rather than dismissing them for being inconvenient. We need to engage respectfully with indigenous knowledge and oral traditions, treating them as potential sources of historical information rather than mere mythology. And we need to accept that some questions may never be fully answered, that uncertainty is a permanent condition when dealing with such deep time, that the value lies as much in the inquiry itself as in any final conclusions. What would our ancestors think if they could see us now, see what we've built and discovered, see how we're trying to understand them across the vast gulf of time? Would they recognize in our cathedrals and skyscrapers the same impulse that drove them to build megaliths and cairns? Would they see in our science the same curiosity that led them to map the stars and seasons? Would they feel kinship with us? Or would we seem alien, our world so transformed from theirs that common ground is hard to find? These are fanciful questions, unanswerable, but they're worth pondering because they remind us that those people were as real as we are, that they experienced their world as immediately and fully as we experience ours, that they deserve more than to be reduced to archaeological specimens or evolutionary stepping stones on the path to our supposed enlightenment. There's a meditation I return to sometimes, standing alone in some ancient place, some cave or stone circle or ruined structure. I try to empty my mind of modern frameworks, try to see the place as its builders saw it, try to feel what they felt. The attempt always fails, of course. I'm too thoroughly modern, too embedded in my own time and culture, to truly access their worldview. But the attempt itself is valuable, the stretching toward understanding, the recognition that different doesn't mean inferior, that ancient doesn't mean primitive. They were solving their problems with their tools, trying to understand their world with their concepts. We're doing the same, just with different details. The underlying human project remains constant across all the changes in circumstance and technology. And that project, fundamentally, is about making meaning. We're pattern-seeking creatures, we humans, driven by deep cognitive needs to find order in chaos, to build explanatory frameworks that make sense of our experience. This drive produces both science and mythology, both accurate models and comforting stories, and often the two are intertwined in ways difficult to separate. Ancient peoples looked at the sun's daily journey and created both accurate calendrical systems and rich mythologies of solar deities. They observed the night sky and mapped constellations, tracked planetary motions, while embedding those observations in stories of gods and heroes. The practical and the mythological were not separate domains but aspects of a unified understanding, a holistic way of relating to the world that we've largely lost in our specialization and compartmentalization. Perhaps there's something we could learn from that integration, from that refusal to separate knowledge into rigid categories. Modern science deliberately excludes subjective experience, personal meaning, questions of value and purpose, focusing solely on objective, measurable, replicable phenomena. This has been enormously productive, has given us understanding and capabilities our ancestors couldn't imagine. But it's also left us with knowledge that feels cold, disconnected from lived experience, difficult to integrate into coherent worldviews that address not just how things work but why they matter. Ancient peoples, for all their lack of formal science, had the advantage of integrated understanding, of knowledge embedded in story and ritual and daily practice, knowledge that addressed both practical needs and deeper questions of meaning. We don't need to choose between these approaches, don't need to reject modern science or romanticize ancient wisdom. We can have both, can pursue rigorous systematic investigation while also maintaining connections to older, more holistic ways of knowing. We can study ancient peoples with scientific tools while also appreciating their worldviews on their own terms, recognizing that different frameworks can capture different aspects of reality, that multiple perspectives enrich rather than diminish understanding. This is what anthropology at its best does, moves between insider and outsider perspectives, tries to understand cultures both through their own categories and through comparative analysis. We should bring that same approach to studying our deep past, should try to grasp not just what ancient peoples did but how they understood what they were doing, what it meant to them. The measurement of gravity, our central theme, provides a perfect example of this dual perspective. From a modern scientific standpoint, we want to know if ancient peoples calculated gravitational acceleration, if they understood gravity as a force, if they developed theories that match our current models. The answer to those specific questions is probably no. They didn't have Newtonian or Einsteinian gravity, didn't formulate universal laws in mathematical terms. But from a broader perspective on knowledge and capability, the answer is yes, they observed and measured gravitational effects, they developed working understanding that allowed practical achievements, they incorporated gravity into their models of the world even if explained through different concepts. Both answers are true, just addressing different aspects of the question. Recognizing this allows us to give ancient peoples appropriate credit without making inflated claims about their capabilities. This balanced approach applies to all the evidence we've examined. Did humans reach the Americas much earlier than Clovis? Probably yes, the evidence is mounting, though exactly when and by what routes remains uncertain. Did they possess sophisticated astronomical knowledge in the Paleolithic? Some groups clearly did by the end of the Ice Age. Earlier evidence is more ambiguous but suggestive. Did they build megalithic structures encoding advanced mathematical and geometric understanding? Definitely yes for the well-studied examples from the Neolithic onward, possible but unproven for earlier periods. Did they measure Earth's dimensions and gravitational properties? They measured many things, developed standardized units related to physical properties, achieved remarkable precision in some contexts. But whether this extended to specific measurements of planetary size or gravitational acceleration remains speculative. These nuanced answers don't make for sensational headlines, don't support grand narratives of lost supercivilizations or ancient astronauts, but they're honest to the complexity of the evidence. They acknowledge ancient capability while avoiding unsupported exaggeration. They keep the inquiry open without prematurely closing questions that deserve further investigation. This is the appropriate stance for anyone seriously interested in understanding our past. Engaged but skeptical, curious but critical, willing to challenge mainstream narratives while also demanding strong evidence for alternative claims. It's a difficult balance to maintain, requires resisting the pull toward either dismissive skepticism that rejects anything unconventional or credulous acceptance that believes every anomaly points to lost civilizations. But it's the balance required if we want to actually learn rather than just confirm our existing beliefs. Let me address directly the tendency toward mystery-mongering, toward framing every unknown as evidence of lost advanced civilizations. This tendency is understandable. It makes for compelling stories. It satisfies our desire for hidden knowledge and our dissatisfaction with mainstream narratives that can seem dry and limited. But it's ultimately counterproductive because it obscures real mysteries with invented ones, diverts attention from genuine questions that deserve investigation into. Speculation about Atlantis or ancient aliens or whatever exotic explanation is currently fashionable. The real mystery is spectacular enough without embellishment. How human intelligence emerged, how it's expressed itself across hundreds of thousands of years, how knowledge accumulates and dissipates, how we got from small bands of African hunter-gatherers to global civilization capable of landing on the moon and sequencing genomes. That story, the actual human story as best we can reconstruct it, is more amazing than any fantasy, more worthy of our attention and wonder. So let's reject false mysteries while embracing genuine ones. Let's acknowledge what we don't know without pretending that gaps in knowledge prove exotic alternatives. Let's investigate anomalies rigorously without assuming they must overturn all established understanding. Let's give ancient peoples credit for real achievements while avoiding inflated claims that diminish their actual accomplishments by comparing them to fantasies. This is how we honor both the evidence and the people who left it, by taking both seriously, by investigating carefully and drawing conclusions proportionate to the data available. We're approaching the end of our journey together, this long meditation on human capability and deep time, on mysteries real and imagined, on what it means to measure the world and our place in it. Before we close, I want to return once more to the personal, to what all this means for you, the individual listening in the darkness, perhaps drifting towards sleep, perhaps engaged in active contemplation. You exist at a specific moment in this vast story, a moment that will itself be ancient history to people centuries hence. You're simultaneously insignificant, a brief spark in cosmic time, and profoundly significant, a carrier of consciousness and culture, a link in the chain connecting past to future. Everything you know, every thought you think, every action you take, rests on foundations built by countless generations before you, foundations they built on earlier foundations, stretching back into depths we can barely perceive. Your body carries genetic markers of ancient migrations, of interbreeding between distinct human lineages, of population bottlenecks and expansions that shaped our species. Your language evolved from earlier languages, changing gradually over millennia but maintaining threads of continuity that linguists can trace back thousands of years. Your basic tools and technologies, farming and metallurgy and mathematics and writing, were invented long ago by anonymous ancestors whose genius you benefit from every day. Your philosophical and religious concepts, your fundamental ways of making sense of existence, have roots in ancient questions and ancient attempts at answers. You are, in very real sense, a product of deep time, a manifestation of the long human project of surviving and understanding and creating meaning. But you're also an active participant, not just a passive recipient of this inheritance. Every time you wonder about something, every time you observe carefully and think critically and try to understand, you're continuing what our ancestors began. Every time you create something, solve a problem, pass knowledge to someone else, you're contributing to the collective accumulation of human capability. Every choice you make about what to preserve and what to discard, what to value and what to dismiss shapes what future generations will inherit from our time. This is not abstract philosophy, it's practical reality. You matter, your attention matters, your choices matter because they're part of the larger pattern, the ongoing story that doesn't end with us. What do we want that story to be? What do we want future archaeologists, if there are any, to find when they excavate our remains? Will they see a culture that valued knowledge, that preserved and transmitted it carefully, that built on what came before while adding new insights? Or will they see a moment of collapse, of knowledge lost and capabilities diminished, a cautionary tale like the ones we've discussed? The answer depends partly on us, on choices we make collectively about education and research and preservation, about how we treat the environment and each other, about whether we prioritize immediate consumption or long-term sustainability. These are not someone else's problems. They're ours. They're yours. They demand engagement from everyone who cares about the future. This is why understanding our past matters so much. It's not just academic curiosity, not just the pleasure of solving mysteries or the satisfaction of knowing how things were. It's practical wisdom about how human societies work, how knowledge is gained and lost, how civilizations rise and fall, lessons bought with enormous costs by earlier peoples and available to us if we're willing to learn. The ancient world is full of examples of environmental degradation, of short-sighted exploitation that undermined the resource-based civilizations depended on. It's full of examples of rigid thinking that couldn't adapt when circumstances changed, of knowledge systems that became dogmatic and brittle. But it's also full of examples of resilience, of innovation under pressure, of sustainable practices that maintained human communities for thousands of years. We can learn from both, from successes and failures, if we study carefully and think critically about how lessons from different contexts apply to our own. And there's inspiration to be found in recognizing ancient capability. When you feel overwhelmed by modern complexity, when problems seem insurmountable, when you doubt human ability to address challenges like climate change or resource depletion or political dysfunction, remember what our ancestors accomplished with far fewer resources. They survived ice ages and megadroughts. They crossed oceans in primitive boats and settled continents without maps or metal tools. They built structures that have lasted millennia. They developed mathematics and astronomy and medicine from scratch, through patient observation and experimentation. They did all this while coping with violence and disease and uncertainty far beyond what most of us experience. If they could do that, we can surely address our problems, can find ways forward if we bring the same curiosity and determination and collaborative effort that they brought to their challenges. But we also need to learn humility from their example. They weren't superhuman, weren't wiser or more capable than us in fundamental ways. They were just people facing their circumstances, doing the best they could with what they had. Sometimes they succeeded brilliantly. Sometimes they failed catastrophically. Often they muddled through, coping rather than solving, adapting rather than mastering. That's what humans do, that's what we've always done. We're remarkably adaptable, remarkably resilient, but also remarkably fallible, prone to overconfidence and short-sightedness and groupthink. Recognizing this in our ancestors should help us recognize it in ourselves, should make us more careful in our own decision-making, more willing to question assumptions and consider alternatives and learn from mistakes. So as this exploration draws to a close, as you prepare to return from this long journey through deep time back to your immediate present, what should you take with you? Take wonder, certainly wonder at the depth and complexity of the human story, at the achievements and mysteries that populate our past. Take humility, recognition that we're not as unique or unprecedented as we sometimes imagine, that we're part of a longer story and should learn from those who came before. Take curiosity, willingness to question accepted narratives and investigate anomalies and remain open to new understanding. Take connection, felt sense of kinship with all those earlier humans who looked at the same stars and asked the same questions and struggled with the same fundamental challenges. And take responsibility, recognition that we're now the ancestors, that what we do and preserve and transmit will shape the inheritance of those who come after. The footprints at White Sands, pressed into mud 23,000 years ago, remind us that every moment was someone's present, was lived with the same immediacy and fullness we experience our own moments. Those people weren't thinking about becoming archaeological evidence. weren't considering how future researchers would interpret their actions. They were living, walking across wet ground because they needed to get somewhere, because that's where the path was, because that's what life required in that moment. Their footprints survived by accident, by fortunate geology and preservation, becoming evidence that challenges our timelines and forces reconsideration of when humans first reached the Americas. But to them, it was just walking, just another day in lives we can barely imagine but which felt as real to them as yours does to you. This is what gets lost sometimes in archaeological discussion, the humanity of it, the individual lives and experiences that lie behind artifacts and data. Every stone tool was held by hands, was created by someone with thoughts and feelings and relationships, someone who learned the technique from another person, who perhaps taught it to their children, who used that tool for specific purposes that mattered in their daily existence. Every footprint represents a person who walked somewhere, for reasons that made sense to them, in a world that was their entire reality. Every bone in ancient burials was once animated by consciousness, by a mind that perceived and thought and felt, that loved perhaps, that feared certainly, that experienced the peculiar mystery of being alive in a universe that gives rise to beings capable of contemplating their own existence. We can't recover those individual lives, can't know their thoughts or feelings or experiences. The vast majority of humans who have ever lived left no trace whatsoever. Their existence now unrecoverable, erased by time without record or memory. But collectively they were us, were human in all the ways that matter, and acknowledging that connects us to something larger than ourselves, something that extends far beyond our individual lifespans or the span of recorded history. We're part of that great continuity of human experience, links in a chain that stretches back hundreds of thousands of years and forward, if we don't destroy ourselves, for an unknowable future. That's simultaneously humbling and elevating, makes our individual concerns seem small while also making our participation in something so vast seem precious. The night sky that ancient peoples studied so carefully, that they encoded in their monuments and mythologies, is the same sky we see, the same stars wheeling in their patterns. The light reaching your eyes from distant stars left those stars years or centuries or millennia ago, traveled incomprehensible distances to arrive at this precise moment and place, to be captured by the biochemical mechanisms of your vision and translated into conscious perception. When you look up at stars, you're literally seeing into the past, seeing light that began its journey before you were born, before your civilization existed, perhaps before humans existed. And you're seeing the same lights that ancient peoples saw, that they wondered about, that they built models to explain. This connects you to them, not metaphorically but actually, through shared perception of cosmic phenomena that transcend the particularities of culture and time. Gravity, the force we've discussed so much, is another universal connection. It pulls on you with the same acceleration it pulled on ancient humans, the same acceleration it's pulled on everything on Earth's surface for billions of years. When you feel your weight, feel the ground beneath your feet resisting gravity's pull, you're experiencing something absolutely fundamental, something that every human who has ever lived experienced in exactly the same way. We've developed sophisticated theories to explain this force, have incorporated it into mathematical frameworks that let us calculate planetary orbits and launch satellites and predict tides. But the experience of it, the felt reality of weight and fall and the pull toward Earth's center, that's invariant across all time. Ancient peoples felt it just as you do. They noticed it just as you do. They wondered about it, tried to explain it in their terms, incorporated it into their understanding. You're connected to them through this shared experience of embodied existence in a gravitational field. These connections matter because they combat the isolation and disconnection that modern life often produces. We live in unprecedented prosperity and technological capability, but also in unprecedented alienation, cut off from nature, from community, from any sense of continuity with past or future. Recognizing yourself as part of the long human story, connected through biology and experience and curiosity to everyone who came before, provides anchor and context, makes the world feel less strange and yourself less alone. You're not an isolated individual adrift in meaningless chaos. You're part of something, heir to vast accumulated knowledge and capability, participant in an ongoing project of understanding and meaning-making that extends far beyond your individual existence. And that project continues, the story isn't finished. Right now, as you listen to these words, archaeologists are excavating sites that will yield new evidence, Geneticists are analyzing ancient DNA that will reveal new migration patterns. Linguists are reconstructing proto-languages that will show new connections. Right now, someone is looking at an old artifact with new eyes, is seeing a pattern no one noticed before, is asking a question that will open new lines of investigation. The human story is being rewritten constantly, refined and expanded and complicated by new discoveries. Nothing is settled. Everything remains open to reconsideration. This is exciting, this ongoing inquiry, this perpetual conversation across generations about who we are and where we came from. You're part of it simply by engaging with these questions, by wondering about the mysteries we've explored, by carrying the curiosity that defines our species. So let these ideas settle into your consciousness as you drift toward sleep or return to your daily concerns. Let them percolate through your thinking, perhaps shift how you see yourself and your connection to the vast sweep of human time. You exist at a particular moment, but that moment is connected to all other moments, to the deep past we've explored and to the unknown future we're building. What you do with that knowledge, how you incorporate it into your understanding and your choices, is up to you. The only request is that you remain curious, that you keep asking questions, that you hold your conclusions lightly and stay open to new evidence and new perspectives. That's what our ancestors did at their best. That's what we should do now. That's what we can pass on to those who come after. As we truly approach the end now, there's one final thread to pull, one last meditation on what all this means. We've talked about knowledge and measurement, about ancient capabilities and lost civilizations, about footprints and tools and stars. But underlying all of it is a more fundamental question. A question that every human who has ever lived has confronted in their own way. What does it mean to be human? What is this strange condition we find ourselves in, consciousness embedded in matter, aware of our own existence and our own mortality, capable of wonder and curiosity and love and fear? The scientific explanations, evolution and neuroscience and biochemistry, describe mechanisms but don't capture the felt quality, the mysterious subjective experience of being a person in the world. Ancient peoples asked this question too, framed it in their own terms, created their own answers in the form of origin myths and religious cosmologies and philosophical systems. They saw themselves as part of nature, connected to animals and plants and natural forces in ways we've largely forgotten. They saw the world as alive, animated by spirits or gods or impersonal forces that demanded respect and relationship. They understood themselves through stories, through narratives that placed human existence in larger contexts of meaning and purpose. These frameworks are different from ours, often incompatible with scientific understanding, but they addressed real human needs that purely material explanations leave unfulfilled. They provided meaning, context, purpose, belonging, things that people need to thrive, things that can't be measured in laboratories or calculated with equations. We've gained enormously through the scientific revolution, through the decision to study nature objectively without imposing human meanings and values. But we've also lost something, lost the sense of enchantment and participation and relationship with the more-than-human world. We're more knowledgeable but perhaps less wise, more capable but perhaps less content. The ancient peoples we've been discussing, for all their lack of scientific theory, lived in a world full of meaning, where everything connected to everything else, where human life fit into larger patterns of cosmic significance. That sense of connection and meaning is something we might need to recover, not by abandoning science but by supplementing it with older, more holistic ways of relating to existence. This is where studying our past becomes personally transformative rather than merely intellectually interesting. By engaging seriously with ancient worldviews, not to adopt them literally but to understand what they offered people, we can begin to see what we might be missing, what we might need to reconstruct in forms appropriate to our circumstances. We need the rigor and power of scientific thinking, absolutely. But we also need myth and ritual and story, need ways of connecting to each other and to the world that speak to emotional and spiritual dimensions of existence. We need to find ways to live that aren't just materially comfortable but psychologically and spiritually satisfying, that provide the meaning and purpose and belonging that humans have always required. The megalithic monuments we've discussed, the stone circles and alignments and passage tombs, served practical functions as astronomical observatories and calendars. But they were also sacred spaces, places where communities gathered for ritual and ceremony, where the boundary between mundane and sacred became permeable. The people who built them were doing astronomy and also doing something else, something harder to name, creating spaces for encountering mystery and transcendence. We've mostly lost that integration, have separated the practical from the sacred, the material from the spiritual, in ways that leave us impoverished even in our prosperity. Perhaps there's something to learn from the ancient integration, from the refusal to separate knowledge into competing domains. This doesn't mean rejecting modernity or romanticizing the past. Ancient life was hard, often brutally so. People died of diseases we can easily cure. They experienced violence and hunger and loss in ways most of us are spared. They were constrained by ignorance and superstition, limited by lack of technology and knowledge. We shouldn't want to return to that, but we can learn from how they found meaning and connection despite those hardships, how they built cultures that satisfied human needs for belonging and purpose, how they lived in relationship with nature rather than trying to dominate and control it. We can take those lessons and apply them in our context, can work toward ways of living that are both materially secure and spiritually fulfilling, both scientifically informed and emotionally satisfying. This is the ultimate implication of recognizing that our ancestors were as intelligent and capable as we are. It means their solutions to fundamental human challenges, to questions of meaning and purpose and how to live well, deserve serious consideration even if we don't adopt them wholesale. It means the long human experiment in living, hundreds of thousands of years of trying different approaches, different social structures, different ways of relating to nature and each other, that entire vast experiment is a resource we can draw on, a library of possibilities we can explore. Not everything they tried worked, clearly, but much did, demonstrably, since we're here as their descendants. Learning what worked and why, what enabled human flourishing across so many different contexts, could help us navigate our own challenges and build better futures. The gravity that pulls us toward Earth's center is also the gravity that holds the solar system together, that governs the motion of galaxies, that shapes the large-scale structure of the universe itself. It's a fundamental force, operating at every scale from the quantum to the cosmic. Ancient peoples, observing its effects, were observing something that connects them to the deepest structure of reality, to the same forces that physicists study with modern instruments. In their own way, using their own methods, they were doing physics, were investigating nature systematically and building working models. They were scientists, and we're their descendants, continuing the project they began, asking the same fundamental questions about the world and our place in it. So perhaps the real answer to our title question, did ancient civilizations measure Earth's gravity before science existed, is this: they measured what they could, observed what was observable, built understanding appropriate to their contexts and needs. They were curious and careful and clever, capable of remarkable achievements when circumstances allowed. Were they us? Not in details, not in their specific knowledge or frameworks or technologies, but in capacity, in drive, in fundamental human qualities of intelligence and wonder and determination. Absolutely yes. They were us and we are them, separated by time but united by shared humanity, by the same basic cognitive tools and emotional needs and existential questions. Recognizing that connection, feeling it deeply rather than just acknowledging it intellectually, changes how we see ourselves and our place in the vast story of human existence. So here we are, at the end of this long exploration, this meditation on human capability and ancient knowledge, on mysteries resolved and mysteries deepened, on what it means to look back across vast time and see not primitives but ourselves reflected in different circumstances. What should you do with all this? How should it change how you think or act or see the world? Maybe it shouldn't, maybe it's just been an entertaining diversion, a story to occupy your mind for a while before you move on to other concerns. That's fine, that's a legitimate use of this time we've spent together. But maybe it could be more, could be a starting point for deeper inquiry, for questioning assumptions you've held about history and knowledge and human nature. If nothing else, I hope this has convinced you that our ancestors deserve respect, that ancient doesn't mean primitive, that human intelligence has been operating at high levels for vast stretches of time. I hope it's made you curious about what else we might not know, what other assumptions we make might be wrong, what other evidence might be out there waiting for someone to notice and interpret correctly. I hope it's given you some sense of connection to deep human time, some feeling of being part of something larger and older and more significant than the immediate present. And I hope it's inspired some wonder, some appreciation for the mystery and complexity of existence, for the questions we still can't answer despite all our advances, for the sheer improbability and preciousness of consciousness and life. The world is stranger than we know, stranger than we can know, full of mysteries that resist easy explanation. But it's also comprehensible, subject to investigation and understanding, revealing its secrets to patient inquiry and careful observation. This tension between mystery and understanding, between the known and unknown, is where we live, where humans have always lived. We push back the darkness with knowledge while simultaneously discovering how much more darkness lies beyond the reach of our lights. This is exciting, is the fundamental human adventure, is what makes being alive and conscious in this universe so remarkable. You exist against all odds at this particular moment in history. The fact of your existence required an unbroken chain of reproduction stretching back billions of years, back through human ancestors and pre-human ancestors and simple organisms to the very origin of life on Earth. Every single one of your ancestors, without exception, survived long enough to reproduce. Not one of them died in childhood before passing on genes. Not one of them failed to find a mate. The odds against this, the sheer improbability of your existence, are incomprehensibly vast. And yet here you are, consciousness emerged from matter, aware of your own existence, capable of contemplating your own origin and wondering about your place in the universe. This is extraordinary, is miraculous even if we understand the mechanisms that produced it. Don't lose sight of how remarkable your existence is, how precious consciousness is, how lucky we all are to experience this strange and wonderful condition. And because it's precious, because it's rare and fragile and temporary, we should use it well. Use your consciousness, your capacity for thought and wonder and understanding. Ask questions, investigate mysteries, remain curious about the world and your place in it. Don't accept easy answers. Don't settle for comfortable narratives. Don't let anyone tell you that all the important questions are settled. They're not. They never will be. There's always more to discover, more to understand, more mysteries waiting to be explored. You can participate in that exploration, can contribute to the collective human project of understanding, even if you're not a professional researcher. You can read and think and ask questions, can engage with evidence and draw your own conclusions, can add your voice to the great conversation about who we are and where we came from. And you can preserve and transmit, can be a link in the chain passing knowledge from past to future. Teach what you know to those who come after you, whether that's your own children or students or simply anyone willing to listen. Tell stories, share insights, pass on what you've learned. This is how knowledge persists across generations, through individual acts of teaching and learning, through people caring enough about understanding to invest time and energy in pursuing it and sharing it. You're part of that process whether you realize it or not. What you choose to value and preserve and transmit will shape, however slightly, what future generations inherit from our time. The footprints at White Sands will eventually erode, will be worn away by wind and water until no trace remains. The stone circles will fall, will be broken and scattered and covered by soil and vegetation. The paintings in caves will fade, will crack and flake and eventually disappear. Nothing lasts forever in physical terms. Everything we build eventually crumbles. Every record eventually degrades. But the knowledge persists if we transmit it, if we care enough to preserve and teach and share. The astronomical observations made by megalithic builders inform our understanding today, 3,000 years later, because someone passed on the knowledge, because enough people cared to maintain the traditions and eventually to study and document them. The oral traditions of indigenous peoples preserve information across dozens of generations because those communities value preservation, because they've developed techniques and practices for maintaining memory across time. We can do the same, can choose to value knowledge and understanding, can work to preserve what's important and transmit it forward. So as you return to your life, to your immediate concerns and daily routines, carry something of this with you. Carry curiosity, carry wonder, carry respect for those who came before and responsibility to those who come after. Carry awareness that you're part of something vast, something that extends far beyond your individual existence, something worth contributing to however you can. And carry the questions, the mysteries that don't have easy answers, the sense that there's more to learn and discover, that the story isn't finished, that human understanding continues to evolve and deepen. Let those ideas inform how you see yourself and the world, how you engage with knowledge and mystery, how you participate in the ongoing human project of trying to understand existence. The stars will overhead, indifferent to human concerns, burning through their fuel on timescales that make human history seem brief as a flash. But we notice them, track them, wonder about them, build stories and theories to explain them. In that noticing, that wondering, we participate in something remarkable, consciousness contemplating the cosmos that gave rise to consciousness. Your ancestors did this too, looked up and wondered, and their ancestors before them, back and back through time immemorial. You're part of that tradition, that long lineage of questioners and observers, and the questions you ask, the attention you pay, the understanding you build, all of it matters, all of it contributes to something larger than any individual life. Before I release you from this long meditation, let me say something about the format itself, about why we structure these explorations in this particular way, slow and contemplative and designed for listening in darkness or drifting toward sleep. There's method here, not arbitrary choice. The human mind in certain states, relaxed but attentive, or that liminal space between waking and sleeping, processes information differently than in focused analytical mode. It makes unexpected connections, sees patterns that rational analysis might miss, integrates information more holistically. The ancient practice of incubation, sleeping in sacred spaces to receive dreams and visions, recognized this, used altered states of consciousness deliberately to access different modes of knowing. We're not claiming mystical revelation here, not suggesting that sleep-adjacent states produce knowledge unavailable to reason. But they do produce different engagement with material, allow ideas to percolate through consciousness in ways that purely intellectual engagement doesn't permit. When you're relaxed, when analytical defenses are lowered, information can sink deeper, can resonate with emotional and intuitive dimensions of understanding as well as rational ones. This is why stories have always been powerful tools for transmitting knowledge, why oral traditions could preserve complex information across generations, why mythology and ritual could encode practical understanding in memorable forms. The material is processed not just intellectually but whole self, engaging multiple dimensions of consciousness simultaneously. The slow pacing, the repetition of key themes, the rhetorical questions that invite contemplation rather than demanding immediate answers, all these are deliberate choices designed to facilitate this deeper, more holistic processing. We're not trying to convince you through logical argument alone, though we've presented evidence and reasoning. We're trying to create an experience, an encounter with deep time and ancient minds that engages imagination and emotion as well as intellect. We want you to feel the connection to human ancestors, not just understand it abstractly. We want the mystery to resonate, to become personally meaningful rather than just intellectually interesting. This requires different approach than standard documentary or lecture format, requires creating space for contemplation and emotional engagement. If it's worked, if you've stayed with this long journey through ancient evidence and philosophical reflection, then you've experienced what we're aiming for. A different way of engaging with historical and scientific material, one that combines rigor with wonder, evidence with imagination, knowledge with mystery. You've learned things, specific facts about archaeology and genetics and ancient capabilities. But you've also, hopefully, experienced something, felt the weight of deep time, sensed the presence of ancient minds grappling with existence, connected to the long human story in ways that pure information transfer doesn't accomplish. That experiential dimension is crucial, is what transforms information into understanding, facts into wisdom. And wisdom is what we need, not just knowledge. We live in an age of unprecedented information access, can look up anything instantly, can accumulate facts endlessly. But information without context, without integration into lived understanding and meaningful framework, is hollow, doesn't actually help us navigate existence or make good decisions or live well. Wisdom requires more, requires reflection and integration, requires connecting information to values and meaning, requires asking not just what is true but what it means, how it matters, how it should shape how we live. This is what ancient traditions excelled at, creating frameworks that integrated knowledge with meaning, that connected practical skills with larger purposes, that embedded individual lives in cosmic narratives that made sense of existence. We need something similar now, need ways of integrating our enormous scientific knowledge with frameworks of meaning and value, need to reconnect information with wisdom. This is partly individual work. Each person must find their own meaningful integration, but it's also cultural work, requires developing shared narratives and practices that serve the functions mythology and ritual served in earlier times. We need stories that incorporate scientific understanding while also addressing existential questions, need practices that connect us to nature and each other and to the deep time we've been exploring. We need, perhaps, a new kind of mythology, one informed by rather than opposed to scientific knowledge, one that can provide meaning and purpose in a universe we understand very differently than our ancestors did. This is ambitious, maybe impossible, but it's worth attempting. And you're part of the attempt simply by engaging seriously with these questions, by wondering about meaning and purpose, by seeking connections between knowledge and lived experience. Every person who does this contributes to the larger cultural project of building post-scientific mythologies, of creating frameworks that honor both what we know about the universe and what we need as humans to thrive within it. This isn't about creating comfortable lies or retreating into fantasy. It's about building genuine understanding that encompasses both objective knowledge and subjective experience, both material reality and phenomenological truth. The ancient peoples we've discussed lived in smaller worlds, bounded by limited geographical knowledge and pre-scientific understanding. But their worlds were also bigger in some ways, full of mystery and significance and sacred dimensions we've largely lost. Every stream was potentially inhabited by spirits. Every mountain was sacred. Every aspect of nature was alive and deserving of respect. This wasn't accurate in scientific terms. There aren't actually spirits in streams. But it produced relationship with nature, produced careful attention and sustainable practices, produced sense of belonging to something larger than isolated human society. We need to find ways to recover that sense of relationship and belonging without returning to pre-scientific worldviews, need to see nature as it actually is, material processes following natural laws, while also treating it with the respect and reverence that earlier peoples demonstrated. This is difficult work, requires holding apparent contradictions together, requires maturity and sophistication to navigate between rigorous materialism and need for meaning. But it's necessary work if we're to build cultures capable of long-term sustainability, capable of providing both material prosperity and psychological well-being, capable of honoring both our scientific understanding and our emotional and spiritual needs as human beings. Ancient peoples can't tell us exactly how to do this. Their circumstances were too different from ours. But they can inspire us, can show us that it's possible to live meaningfully and sustainably within nature's limits, can provide examples of how knowledge can be integrated with wisdom, how practical capability can coexist with reverence and wonder. So take that lesson too from this exploration. Don't separate knowledge from meaning. Don't treat scientific understanding as opposed to emotional and spiritual fulfillment. They're not enemies. They're complementary dimensions of full human existence, and we need both. Study the world rigorously, understand it as deeply as possible through systematic investigation, but also relate to it personally. Find meaning and beauty and wonder in what you discover. Let knowledge inform how you live, rather than remaining abstract information disconnected from experience. This is what we mean by wisdom, this integration of knowing and being, this transformation of information into lived understanding. We've reached the end at last, the conclusion of this long journey through deep time and ancient achievements, through mysteries resolved and deepened, through evidence and speculation and philosophical reflection. 20,000 words, hours of listening if you've stayed through it all, a substantial investment of attention and energy. Thank you for that investment, for your willingness to engage with complex material, to sit with uncertainty and ambiguity, to wonder alongside me about questions that don't have easy answers. This kind of deep engagement is rare in our fragmented attention economy, is valuable precisely because it's difficult, because it requires sustained focus and openness to ideas that challenge comfortable assumptions. What have we established through all this exploration? We've seen that human presence in the Americas extends further back than Clovis, that sophisticated capabilities existed deeper in prehistory than conventional timelines suggest, that knowledge can be lost and rediscovered across cycles of cultural rise and fall. We've examined specific evidence, tools and footprints and structures and genetic data that points toward more complex narratives than simplified models allow. We've considered how ancient peoples might have possessed practical understanding of physical forces like gravity even without formal scientific theories. And we've reflected on what all this means, how recognizing ancient capability connects us to deep time, how fragile knowledge is and how precious consciousness is, how we're part of something vast and ongoing that transcends individual existence. But beyond specific claims and evidence, I hope this has been an exercise in a different way of thinking, a different way of engaging with the past and with knowledge generally. A way that balances skepticism with openness, that demands evidence while remaining willing to question established narratives, that combines intellectual rigor with imaginative engagement, that sees ancient peoples as worthy of respect rather than condescension. This approach serves us well not just in studying history but in navigating life generally, in assessing claims and building understanding and making decisions about what to believe and how to act. We live in times of tremendous uncertainty and rapid change, times when many people feel unmoored from tradition and community, when old certainties have dissolved and new ones haven't yet emerged. Looking back to our deep past, recognizing our connection to the long human story, can provide some of that grounding we're missing, can remind us that we're not the first to face uncertainty and change, that humans have navigated disruption and transformation many times before. We can draw strength from that recognition, can feel less isolated and more connected to something larger and more enduring than our particular moment. The night deepens as you listen, or perhaps dawn approaches, or perhaps you're in some other time zone where day progresses toward evening. Wherever you are, whenever you're listening, the stars turn overhead unseen. The Earth spins on its axis. Gravity pulls you gently toward the planet's center just as it pulled on your ancestors and will pull on your descendants if we leave any. These are constants, unchanging realities that connect all moments and all peoples. And your consciousness experiencing this moment, wondering about these questions, is itself a constant, the same fundamental human awareness that has looked out through countless eyes across hundreds of thousands of years, always wondering, always curious, always trying to understand. You are a carrier of that consciousness, a temporary expression of the universe's ability to become aware of itself. You're made of stardust, literally atoms forged in ancient stellar furnaces and scattered through space by supernova explosions, atoms that found their way to this planet and eventually into the configuration that is you, aware and contemplating your own existence. This is not metaphor or poetry. It's physics, cosmology, the actual history of the matter that comprises your body. You are the universe looking at itself, asking questions about its own nature and origin. This is extraordinary, is miraculous even if we understand the mechanisms. Never forget how remarkable your existence is, how precious consciousness is, how lucky we all are to participate in this strange and wonderful experience of being alive. And with that, I'll let you go, release you from this long meditation to return to your life, to your immediate concerns and daily activities. But carry something of this with you, some fragment of wonder, some curiosity about mysteries we've explored, some sense of connection to deep human time and to the ongoing project of understanding that defines our species. Look at the stars sometimes and remember they're the same stars ancient peoples mapped and wondered about. Feel your weight against the earth and remember gravity has pulled on everything in this same way for billions of years. Ask questions, seek understanding, remain curious about the world and your place in it. This is what we do, what humans have always done, what makes us who we are. Sleep well if you're drifting toward sleep. Dream of deep time and ancient minds and the long human story that continues through you. And when you wake, carry the wonder with you into the daylight world. Let it inform how you see yourself and engage with existence. You're part of something vast and ancient and ongoing, something worth honoring through how you live and what you value and what you pass forward. That's the ultimate lesson, the deepest wisdom from our exploration of ancient knowledge. You matter, your attention matters, your participation in the human project matters. Act accordingly. Live well. Stay curious. Thank you for listening. Be well wherever you are, whenever this finds you. The story continues, and you're part of it.